Okay, hey everybody. We are going to talk about electronegativity really quickly. Make sure we understand that concept because this is the concept that we build on understanding like polarity and polar bonds. Whether or not a molecule is polar or nonpolar, you have to understand electronegativity first, okay? So, in general, all right, the kind of definition of electronegativity is not difficult for a concept, okay? And it says it kind of right here, right? Right? So electron, so has to deal with electrons. And negativity. Sounds bad, but what are electrons? Electrons are negative, right? So the ability to be negative. Basically what this is telling you, and it's right there in its name, okay, is it is the ability of an atom to attract an electron to become negative, okay? Okay, so it is the ability of an atom to attract an electron and become negative, okay? So if you are looking at your beautiful periodic table, okay, you want to figure out which atoms are high in electronegativity, so which atoms are going to attract those electrons, and which atoms are low in electronegativity, which means they won't attract electrons, okay? So the way I like to think about it, which might be ridiculous, but I like to think about it as which atoms are the most attractive, right? Because they are in fact attracting electrons, okay? So who's the best looking of the bunch? You know, who's going to attract all those electrons? Like, come on over here, electrons, okay? And if you just kind of think about our atoms on the periodic table, okay, our elements here, the elements that actually want electrons are going to be your nonmetals, right? These are already elements that are going to form negatively charged ions. So these guys already wanted electrons to form full valence shells, right? The guys who really don't want electrons, who are not attractive to electrons at all, okay, low men on the totem pole here, okay, are your alkali metals, your alkaline metals. Metals don't want electrons. They want to get rid of electrons, actually, right, to form full valence shells. So things on the left part of your periodic table, not going to be high in electronegativity. Things on the right are going to be high in electronegativity, okay? And there's actually a trend here. So again, we're looking at the ability to attract an electron. So in general, okay, if I'm looking at a general kind of trend, a general pattern, okay? Noble gases don't want to attract electrons. They already have a full valence shell, right? So for the trend of electronegativity, you can, in your mind, kind of just think like these noble gases, not going to be part of my trend for electronegativity, okay? Now, if you want to get super technical, yes, your lower noble gases, okay, the more heavy noble gases can actually attract electrons, but just for what we're doing in Chem 2A, I think it's easier to conceptually think these guys already have a full shell, right? They have a full valence shell. They don't want electrons. They're not attracting any electrons. They're happy and stable, okay? The guys that are going to attract electrons next are going to be what's right next to your noble gases, right? So fluorine, for example, is actually the most electronegative element, right? Fluorine right here next to your noble gases. Okay, so these guys up top and to the right are going to be the most electronegative. And then the guys at the bottom and to the left, okay, so over here are going to be the least electronegative, which means my overall trend, okay? My overall trend is that elements get more and more electronegative as you go across from left to right on a period. Electronegativity will increase. And as I go up a group, my electronegativity will increase the further and further up I go, okay? So my overall trend is just, you kind of put those two directions together, okay, is up and to the right. This is my overall trend for electronegativity, okay? So you might be given questions like this, right? Which of these are the most electronegative? Okay, and you might have to compare some atoms or compare some elements, okay? So remember that our trend is up and to the right, okay? And if I was comparing calcium versus arsenic, okay, I'd have to first find them both on the periodic table. So here's calcium. And on the same period on my periodic table, here's arsenic. Hopefully you don't hear my kids in the background. I apologize, okay? Arsenic is further to the right, and they're both on the same period. So arsenic, following the trend, is going to be more electronegative. So in this case, this guy is more electronegative, okay? If you want, you can like pause real quick and see if you can solve these by yourself, and we'll come back and answer, all right? But I'm gonna continue on, okay? If you had bromine versus fluorine, okay? You find them both on your periodic table. Here's bromine, here's fluorine. Okay, they're in the same group now. So fluorine is going to be more electronegative than bromine because it is further up, okay? They're both in the same group, so nothing is further to the right, right? So just fluorine's further up, so fluorine is more electronegative than bromine in that case, okay? If I had chlorine or selenium, okay? Here they are, Cl and Se, okay? Chlorine in this case is both further up and further to the right, okay? So following the upward and to the right trend, right? Chlorine is gonna be the more electronegative of these two elements. Then you get something like this, O or Cl. And now you're up-ish creek, right? Because oxygen is technically further up from chlorine, but chlorine is technically further to the right. So which of these two is going to follow the trend, okay? We learn a little thing called FONCl BrISCH. Okay, so this might sound ridiculous. I'm sure it does. It did to me when I was first learning it, but FONCl BrISCH, okay? These are the 9 most electronegative elements. I mean, technically there's like selenium that fits in here, but we don't do a lot of bonding with him. Okay, so FONCl BrISCH. So fluorine is going to be your number 1 most electronegative. Oxygen gets 2nd place, nitrogen gets 3rd place, right? So number 2, number 3, chlorine, bromine, iodine, sulfur, carbon, and hydrogen, okay? Then after I go through these 9, after I get to hydrogen, then I just follow the trend, which is up and to the right, okay? So if you are getting confused about which of these elements, like FONCl BrISCH, okay, which of these elements kind of up in this upper right-hand corner are more electronegative, like if I'm comparing chlorine or oxygen, you just follow FONCl BrISCH. All right, so this guy, oxygen or chlorine. If you're just looking at a periodic table that doesn't give you electronegativity numbers on it, and it's just like this, there's no way for me to tell because oxygen's further up, but chlorine's further to the right. So the only way for me to tell between these two, which one's more electronegative, which one is more attractive to those electrons, right? Come hither electrons, is to follow FONCl BrISCH. FO, okay, O wins the day. O is more electronegative than chlorine because he comes first in FONCl BrISCH. So in this case, wrong color, but who cares, okay? So, all right, this also becomes important. These 3 letters become important when we start learning about hydrogen bonding. Okay, this will all make more sense in a bit, but just to kind of prep the waters for you here, okay? The 3 most electronegative elements when they're bonded to hydrogen, because they're so electronegative, they really want those electrons, they will form a thing called hydrogen bonding. And that's because they are the most electronegative elements on the periodic table, okay? So that's pretty much it in general for electronegativity. Just understand the trend and understand why, right? Things to the right side, my nonmetals, they want electrons to make a full shell. So they are going to be attracting electrons, okay? Things on the left-hand side of my periodic table, they don't want electrons. They want to get rid of electrons to have a full shell. So they will not be electronegative, okay? High electronegativity, low electronegativity.